Okay, we have here another interesting integral from the UNSW integration bee from 2024, problem 3. We have the integral from 0 to 1, x to the 6th over x plus 1 dx. Okay, so let's get started with this. The first thing I notice here is just the fact that we have a higher degree in the numerator. We've got a 6th power here, and this is just first degree in the denominator. So what you could do here is polynomial long division, but I usually like to try to take a shortcut if I can. So what I'm going to do is I just want to subtract 1, because then I can factor this x to the 6th minus 1, but I don't want to change it, so I'll add 1. And what that's going to allow me to do first is just split this up into two integrals and rewrite it. So the first one, we're going to have this x to the 6th minus 1. And then for our second integral, we'll just take this 1, and we'll just write it like dx over x plus 1. Now, the second integral is going to be pretty easy, but what I want to do is focus on how are we going to factor this x to the 6th minus 1. What you could do for a factoring here is first use difference of squares and then use difference in sum of cubes in order to get this factored and then get some cancellation. What I want to look at instead is a couple formulas, a couple different ways that we can factor this. Okay, so now we have these two factorings over here to the right. Now, this second formula only works when you have an even exponent. If you have an odd exponent, there's a similar formula with a plus sign here, and it works out basically the same way. For this first formula, it works for basically any integer exponent. It doesn't matter if it's even or odd. But now to figure out which one of these I want to use in this integral, it's real easy because what I want to do is I really want cancellation with the x plus 1. So as far as that goes, this first one doesn't really help me. I'm going to want to use this second formula right here. Then all I want to do is just take this and we'll plug this back into our numerator and continue from there. Okay, so now that I have this whole thing rewritten, again, this whole numerator, this is just our x to the 6th minus 1 value that we factored on the previous board. And now you see we have our x plus 1 here, so I'm going to just cancel this with this. And what that allows me to do is now this whole thing is just a polynomial, so we can just use power rule here, and we have an easy integral over here. So let's go ahead and we'll just integrate this, and so this is going to become x to the 6th over 6th minus x to the 5 over 5 plus x to the 4 over 4, and then what am I doing? Oh yeah, and then here this is going to be x cubed over 3, and this is x squared over 2, and they just gave us a lot of terms. So then we have a minus x there, and then here we'll just include this one. So this is going to be, this one here is going to be natural log absolute value x plus 1, and we are just going to do evaluate from 0 to 1. But the bounds are pretty nice. It's going to be pretty easy to evaluate 0 and 1. So evaluating at 1, we're going to end up with 1/6 minus 1/5 plus 1 over 4 minus 1/3 plus 1/2 minus 1. And then here we're going to have this just going to become natural log of 2. And then for the second part, we're going to subtract. We plug 0 in though. This is a polynomial, even the last term 0. So all that's 0. And then here, plus plugging 0 in here, we're going to have natural log of 1. But natural log of 1, 0, so this whole part goes away. So then in order to finish this off, I just need to simplify all these fractions here really quick. So now let's put the natural log 2 in front of this. And then for all this, what I need to do is I need to get a common denominator. So you notice what works for a common denominator here is going to be just 60. So for 1/6, we're going to have, this is going to become like 10 over 60 is the same as 1/6. And then minus 12 over 60 is minus 1/5. And then this is going to be a 15. And this is going to be a minus 20. And this is going to be a plus 30. And then minus 1, we can write that like minus 60 over 60 is minus 1. But then if you just add up all this stuff right here, add and subtract everything here, this becomes minus 37. So for my final solution to this, we're going to end up with just natural log 2 minus 37 over 60. Okay, finished it just in time for the alarm to go off. So good problem from UNSW 2024. Thanks everyone for watching. Have a good day.